updating the screen. So let's go all the way down to my thread here for my canvas view. A thread being something that you can run in the background. So I have this method here, or sorry, this thread here called update UI thread. And this is what we're going to run every 28 milliseconds, or so we hope. If you have a slow tablet or a slow smartphone, you can't guarantee it's going to run at every 28 milliseconds. Just to give you an idea, 28 milliseconds is 35 frames per second. Sounds about right. So you can change that value if you want a slower or higher frame rate. I don't think you can go higher than 35 on most devices now. For these 2D graphics, you'll start to see a lot of choppiness if you go too high or too low. So we found 28 milliseconds was the sweet spot for us. You just kind of have to play around with that. So I kind of expect that you have a knowledge of how to create a thread. I can give you kind of a basic rundown of what's going on inside the thread here. I grab the current time. That current time is what's going to be used to update each of our objects. Remember from our spaceship class, when we want to move it, we have to feed it an update time, how many milliseconds since the last update. And then we also have, last update here, it just takes the game start time and minuses, or the game's current time and minuses it from the last update. And then we have the third last most important thing to your game, which is a method that updates all your physics, everything on screen. This is where all of your animation happens. Okay? So let's go take a look at update physics now. There's a lot of stuff here. There it is. Okay, so update physics. Okay? So it takes one method, one parameter, which is the last update time. Let's say it's like 20 milliseconds, right? It could receive a value such as that. I have all these if statements here, and these if statements are just to check, for example, this one finds out whether a bomb has been fired. And then it basically will display a flash on the screen, so it kind of imitates a bomb exploding. And then that also takes care of deleting all the avatars on screen. Then we have if an avatar has hit the house. So if an avatar makes it all the way to the bottom of the screen, we actually have to destroy the house a little bit. And what we actually do is we kind of display cover the whole screen in red, so it's kind of like you got hit and you actually realize it. So that's what this if statement deals with. And these only run, so obviously it checks these every, let's say like 28 milliseconds, we hope it runs, right? So every 28 milliseconds, it's checking these statements to see if an avatar has reached the bottom of the screen, if a bomb has been fired, if the spaceship is moving left. This is an important one. So if the spaceship is moving left, which we find out just by checking if the button has been pressed, the left button, we actually want to call that method move left on the spaceship. So that spaceship, we actually have to move it to the left. We feed it the last update time. And as you saw earlier, what happens there? Same thing for moving right. The next one takes care of the lasers. So this one goes through all of the lasers. It iterates through them using an iterator here. And it's going to, if they haven't reached the bottom of the screen, okay, which we'll take a look at this if statement in a second, it's actually going to call this move up method. So the laser, instead of having it's called an invader's laser, you can take a look at that class. It has just a move up method, as opposed to the spaceship where it has move left and move right. Because it moves up on the screen, that's its method, and it changes the Y value to deal with that. But we also have an if statement here that if the bottom of the laser is less than 0, meaning the bottom of the laser has reached the top of the screen, which would be the 0 pixels point for the X value, we want to remove that laser from our array list that I showed you earlier, and it's going to just delete that. It's no longer going to draw it on the screen. Okay. The next one takes care of the list of avatars. It iterates over all the lists, every avatar in the list, and then it's actually going to move every single avatar down a little bit based on the last update. So as opposed to the laser, which moves up on the screen, all the avatars move down. So we have a move down method in the invader's avatar class. And then same thing, if the bottom of the avatar is greater than the actual height of the screen. Now keep in mind, when you're thinking about the screen in terms of pixels, the Y value of 0 is all the way at the top. So what's the size of this again? It's 1280 in height. So 0 pixels for the Y axis would be all the way at the top, and 1280 would be all the way at the bottom. Okay, so make sure you think about that. And for the X values of where things are on screen, 0 is all the way to the left of the screen, and it's 800, right? Yep. Pixels wide. So 800, that pixel value would be all the way to the right of the screen. So make sure you think about that when you're designing these methods here. So we grab, as I said, grab the bottom of the avatar, and if it's reached the bottom of the screen, if it's greater than the bottom of the screen, we need to remove that avatar, and we call a method here, destroy house, okay? Which destroys a little bit of a chunk off the house. You saw Greg playing, you know, because he's so bad at the game. Every time an avatar hits the bomb, it takes a little chunk off of the house. So
this gives you 3 chances to kind of, instead of just the 1.
Yeah. So yeah, I think it's 3 hits before the whole house is destroyed. Then we have our list of bombs. Okay, there's really never a point where there's more than 1 bomb on the screen, but we track it in an array anyways. Just we always want to think about the future. Maybe we're going to have more than 1 power up on the screen, or maybe more than 1 bomb later on. We decide. We do iterate through the array of it anyways. And then same thing. It moves the bomb down just like the avatars. And the way you actually grab the bomb is you actually shoot it, and it takes that item into your inventory. Then same thing, if the bomb is at the bottom of the screen and it's about to move off, it deletes it from the array list. What else we got going on here? Oh, we have timers, okay? So it's not an actual timer. This is just a value that I hold on to that kind of tracks the amount of time. Every time this update physics thing is run, I add the amount of the last update to it. So every time this runs, assuming it runs every 28 milliseconds, it's going to add 28 milliseconds to this integer timer here. And then after that, after it's added the last update time, it's going to check if that combined value of all the last updates is greater than the frequency that I want the avatars to move down the screen. If it's greater, then it's going to add a new alien. So this is where we add all the new aliens. So I take that list of avatars and I add a new invader's avatar. We can actually see how the constructor is called here with all the different values. You can remember we took a look at the class earlier, and it had all the parameters. The first one, it requires a context. So I would call every single view class, because we're extending view, I can just call get context, and it'll get a nice easy context for me. Sometimes it's hard to find context within an app, but in this class it's very easy. It's a very easy method to call. Then we want to create, this is the X, whoops. This right here that I've highlighted is the X value of where I want the avatar to start. So I take that random, that instance of random, and I just take the screen width. I minus, you can see 70 pixels off of it, just so that the avatar isn't actually fully off the screen. And then it applies that as an X value. I always apply a value of -70 to the avatar so that it starts off screen. That's for the Y value. And then I actually, and this would have been actually good to look at a little bit earlier, I'll show you it in a bit, is the list of avatar bitmaps, okay? This is actually an entire array list of all your Twitter friends. Actually, I didn't grab all of them. I think I grabbed 50 of them. Obviously, I didn't want to load every single friend in your timeline. So I grabbed 50 avatars or less, depending how many friends you have.
I end up shooting the same people.
So you can adjust that value. It might take longer for the game to load if you put too many, because it does have to load every single bitmap at the beginning of the game. So all I do is I grab a random bitmap out of there, one of your random avatars, and put it into that avatar and put an alien skin on it. Okay? It's important that you take that timer that's kind of tracking how many last updates there's been, and it actually resets it to 0. We have another timer here for the bombs, okay? And same thing, it works the same way as the avatar timer. And so if it reaches how often I want the bombs to be displayed, I actually create a new bomb and add it to the array. Now, you can see, this is important here too for games. You're gonna notice that you might get a lot of exceptions when you first start your game. I kind of found this out by just trial and error, that I got an exception called concurrent modification exception, which meant because I have a thread running in the background and I'm updating the UI, the UI is interacting with my array lists of all my elements, and so is my background thread. Because they're both accessing the same array list and they're modifying data on it, both at the same time, you're going to get obviously a concurrent modification exception. It's like,
I hate getting those.
It's like me. It's like Greg holding his phone and he's playing with it and I'm trying to play with it at the same time. It's just, it's not going to work out. So that's why they throw that exception. So if you include all your modifications to your array list, if you include it in a synchronized block, to make a synchronized block, you just say synchronized. You give it a context or the activity. No, sorry, it's a context, yes. And you just put everything within that block. I think I did it all the way down till here. So when I'm editing the avatars and when I'm editing the bombs, I synchronize those to make sure that if the thread's dealing with them, the UI doesn't touch them. That's all it does. It's very, very cool and very helpful for that exception that you might find. Another tip.
Your game can slow down and you can have a lot of different types of bugs. Some of them will throw you an error, others will, it'll affect gameplay. Like if you have the main UI running certain things that it's not supposed to, it won't lock up, but you can have some.
Yeah, well, the thing is, I'll talk about it after I'm finished going through all the code here. You also have to consider memory. When you're creating a game, your phone only has so much memory. It's a mobile device, there's not a whole lot. You have to be very careful of how the garbage collector runs, how many objects you're creating, make sure you're recycling the objects properly. I'll talk about that in a bit. So these two for statements, they iterate over the list of arrays and the list of bombs again. And this is where collision detection occurs. Okay, so collision detection is not a difficult thing to do because of the rectangle class we implemented. Because every single object on screen, I've applied a rectangle instance to it, I can easily check when stuff bumps into stuff. So every time this update physics method is called, it's checking for collision detection. And because it's iterating over every single alien and every single laser, you might think that it's doing a lot of work. They're very fast devices. They can do all of this very quickly. But let's take a look at the actual collision here. So I'm iterating over my array list of aliens, my list of avatars here, and I'm iterating over my list of lasers. Okay, and so I go through and I say if avatar.hasCollision occurred. Okay. So the avatar class, I didn't take a look at this when we were in the class, but let's take a look now. Keep in mind here I'm giving it a parameter, which is a laser. I feed it a laser object, invader's laser object. Invader's avatar. At the bottom, has collision occurred? Okay, look how simple collision detection is. Okay, it returns a Boolean, so whether or not a collision has occurred. So as I said, here's the parameter, gets an invader's laser. All I do is I take the rectangle of the avatar, so the actual space that the avatar holds, and I call this method called intersect, and it finds out if this laser, if its rectangle is overlapping the avatar's rectangle, okay? And it could be anywhere. It doesn't have to be fully inside of it. They do have nice methods here. Let's take a look at a couple of the other ones they have as well. All I care about is if they're overlapping at all.